Algebra 2, zero multiplicity and relative maximum minimum. So there's really two core concepts we're talking about in this video. Zero, now zero, another word for zero is root, and this is essentially the x-intercept of a graph. So if you hear me say 0, root, x-intercept, all three of these are talking about the same thing. Multiplicity has to do with the amount of times a root represents a factor. So the number of times a root represents a factor. So multiplicity is the number of times a root represents a factor. I abbreviated represents there. Relative maximum and minimum, these are basically the peaks and valleys we're going to see in the curve throughout. But let me show you some examples, and all of this will become, hopefully, a little bit clearer. All right, so what you see here is a lot of functions drawn in two ways. This is polynomial form right here, and then this is factored form right here. But this is the same thing. So if I were to factor x squared plus x minus 6, it would factor to x plus 3, x minus 2. And this is the graph of that function. So if you type f of x into your y equals part of your graphing calculator, you'll get this picture. Now, a couple of things. Now, we know a little bit about what degree is. Degree is the highest exponent of the function. So in polynomial form, I just look for the highest exponent. I say it's x squared. So this is a degree 2 function, a quadratic, a parabola. If you're trying to find the degree from a factored form, you basically count the x's. I see 1, 2. Now, first of all, what are the zeros? Zeros and multiplicity. But first of all, what are the zeros? Like x equals what? What are the x-intercepts? They come from the factors. If I set this equal to 0 and solve, I get x equals 3 and x equals 2. Sorry, x equals negative 3 and x equals positive 2. So the zeros are x equals 3, negative 3, and x equals positive 2. Now, what are their multiplicity? Now, multiplicity is essentially how many times does this root represent a factor? Now, I only have one factor of x plus 3, so its multiplicity is 1. And I only have one x minus 2, so its multiplicity is 1. So this is a pretty boring, pretty basic example here. When you get to the other ones where you see I have multiple x minus 2's, that's when you're really going to understand what multiplicity is. But for now, it's just a basic parabola. I have a root here at negative 3. And I have a root here at positive 2. They each have multiplicity 1. Now, how about a relative max-min? I do have one of those. I have a relative minimum right here. This would be called a relative minimum. And it's essentially a low part on the graph. Now, in this case, it's actually the lowest part on the graph, but it doesn't always have to be that way. Which we'll see in a few more examples. But I see it is kind of the bottom part of a curve where the graph is decreasing and then it goes to increasing. And that's what max-mins are. It's where the graph changes from increasing to decreasing or decreasing to increasing, something like that. So let me show you this next example. This function, g of x, in polynomial form here and in factored form here, I see it has a degree of 3. Highest exponent is 3, 3x's. But how many roots does it have? It has degree 3, but it only has 2 roots, 2 zeros, 2 x-intercepts. 1 at negative 3, and then 1 at positive 2. So I have x equals negative 3, and I have x equals positive 2. But you'll notice that there are 2 factors of x minus 2 that give me a root of x equals 2. So what we say is that that factor, that root, that 0, x equals 2, has a multiplicity of 2 because it comes from 2 factors. You only see one x-intercept from them, but because it comes from 2 factors, it has multiplicity of 2. So right there, a couple of things. Our degree does not necessarily mean how many x-intercepts we're going to have. The x-intercepts, the zeros, the roots, you can have at most as many as the degree. So if you're degree 3, that means I could cross 3 times or fewer. And the way the or fewer works is that some of your roots may have multiplicity. Or you could have some imaginary, which I'll get to later on. So this one has negative 3 has a multiplicity of 1 because it only comes from one factor. But this root of x equals 2 comes from two factors, so it has multiplicity of 2. And one multiplicity with two multiplicities still gives us a degree 3 function. So degree 3, we can have two roots, or we could have three roots, or we could have one root. We'll get to that. But you can't have more than that. If our degree is 3, we can have at most 3 roots. But we can have fewer than that. We can't have more than that. And multiplicities. Now, one thing here. Notice there's two different types of roots here. This one right here is what I call a crossing root. See how it crosses the x-axis, goes from the negative side to the positive side. And then this type of 0 right here is what I call a bounce. You see the graph kind of bounced off of it right there? I just want to write that word a little clearer. And so the graph is bouncing. It doesn't cross the x-axis. It just hits the x-axis and then bounces away. And really what we call is the x-axis is tangent to the graph at this point, but we can refer to it as a bouncing root. And what's significant about that is when we see a crossing root like this, that means that that root has odd multiplicity. So that means that that root's going to come from one factor, like it does here, but it could come from 3 or 5 or 7 factors. And when you see the graph bouncing at a root, that means that that specific root has even multiplicity. So crossing has odd multiplicity, and bouncing has even multiplicity. And so the fact that I'm seeing it bouncing here tells me that there's going to be more than one factor, 2, 4, or 6 factors that produce this one root. How many relative max-mins are there? Well, in this case, I have a relative max right here. This is a relative max. And this is a relative min. The graph goes from increasing and then starts decreasing at this point. It's decreasing and then it changes to increasing again. So those are relative max and mins. Are these the highest and lowest spots on the graph itself? No. Like the graph goes all the way down to negative infinity down here. It's much lower than this spot. So the relative min is not the lowest and the relative max is not the highest point of the whole graph, but it is where the graph changes from increasing to decreasing. But in this case, there are two. And the way that that's going to work is the zeros, you can have as many as your degree or fewer. The max mins, if our degree 3, we can't have 3 max mins. The most we could have is 2. The most max mins you could have is 1 less than your degree, but you can't have fewer. So let me show you a couple more quick examples. All right, this is a degree 3 function. It's got x minus 1, x plus 1, x plus 2, so it's degree 3. Its zeros are 1, -1, and -2, all with multiplicity 1. See, it's 1, 2, 3. They all only show up once. Relative max and mins, there's 2 there. Now this function is also degree 3, but there's only 2 zeros, one at -5 and then one at -1. So we would say that we have x equals -5 with a multiplicity of, ugly m, 1, but we also have x equals -1 with a multiplicity of 2 because it's coming from 2 factors. Ugly x, sloppy. But we have 2 relative max mins. Again, 1 less than the degree. This one here, this next one, is also degree 3, but notice that we only have 1 root. We only have 1 root at -2. So x equals -2, but it has a multiplicity of 3 because there's 1, 2, 3 factors that produce that 1 root. So it's possible to have 1 root with much more multiplicity than 1. And it is crossing, so I know it's an odd amount. Kind of looks like it's riding the axis here. It's not. It just gets very close and only crosses at that one spot. And how many relative max mins? In this case, there are 0. So don't get in the habit of always thinking whatever the degree is, it's 1 less than that. Whatever the degree is, it's 1 less than that. It can be even less than that. So if you're degree 3, you'll have at most 2 max mins. But in this case, we have 0. And then there's the last case. This is also a degree 3. And there's only 1 root, -2. So x equals -2. but its multiplicity isn't 3 like it was here. Its multiplicity is 1 because there's only one factor of x plus 2. So where are the other roots? Well, x squared plus 5 is not a factorable term, and this is going to produce imaginary roots. And we're going to talk more about imaginary roots in another chapter. Just for now, you need to know they can exist, and if they do exist, they always come in pairs. So you see there's going to be 2 imaginary roots here. If you set that equal to 0 and solved it, you'd end up with x equals plus or minus the square root of -5, which is imaginary. You can't do the square root of a negative number. Again, I don't want to talk too much about that now. It's really not the point. But you can have a couple imaginary roots paired with a real root. Now, they are imaginary, but they are factored into the degree 3 here. How many max mins? Again, in this case, 0. So we could have as many as 2 because that's one less than the degree, but often it's less than that. So just looking at these 4 examples real quick, these are all degree 3. We could have degree 3 with 3 roots. We could have degree 3 with 2 roots, where one of them has multiple multiplicity. Or you could have degree 3 with 1 root, which is in both of these cases. They're both degree 3 with 1 root, and that could happen when either that 1 root has multiplicity 3 or a couple of imaginary roots are involved. As far as number of relative max mins, it could be as high as 1 less than the degree, but it could be even less than that. One last question. I know this number is getting high, but I'll run through this fast. Here we go. One more problem. What's the degree? Well, this is in factored form. The degree is 5. Now, if you just count x's, you think in 1, 2, but there's 3 x plus 2's and 2 x minus 1's. So this would be x plus 2, x plus 2, x plus 2, x minus 1, x minus 1. So the degree is 5. The maximum number of possible zeros is equal to the degree 5. The maximum number of possible relative max mins is 1 less than the degree 4. How many actual zeros are there? 1 here, 1 here. We could have as many as 5, but there's actually only 2. X equals -2 with a multiplicity of 3 because we have x plus 2 3 times. And x equals +1 with a multiplicity of 2 because there's 2x minus 1's that when you set them equal to 0 and solve, you get x equals 1. The actual number of relative max mins, we could have as many as 4, but I see only 1 relative max, 1 relative min, so there's really only 2 there. So it's important to know the possible amount you could have, but it's also then we can use our graphing utility and factoring and stuff to find out the actual number of these things. So that's multiplicity, relative max mins, and a lot of graphing stuff involved. So we're going to discuss a lot more of this in class.